Hello everybody, I am Dr. Garuma Abdisa, and in this tutorial we will briefly talk about the basics of vectors. In physics, physical quantities are either scalars or vectors. A scalar is any positive or negative physical quantity that can be completely specified by its magnitude. Examples of such physical quantities are like mass, energy, time, temperature, volume, charge, speed, distance, and so on. A vector is any physical quantity that requires both a magnitude and a direction for its complete description. And the examples of such quantities are like velocity, displacement, acceleration, force, momentum, torque, weight, electric field, and so on. Now we briefly talk about the vector representations. Vectors are represented with a letter with arrow over it. For example, this letter A with arrow over it shows a vector having a tail and head. This is another vector, vector B, and this line is called the line of action of the vector. Or we represent the vectors using bold-faced letters, such as bold-faced letter A and letter B as you see here. Now let us move on to vector addition. There are mainly two categories of vector additions. One is vector addition using the triangle method, and the other one is vector addition using parallelogram method. Let this be vector A, and this be vector B. And then using the triangle method of vector addition, we can join these two vectors to form a triangle, as you can see here. And R is the resultant of the two vectors, and as you can see here, vector B and A are joined head to tail to form a triangle. This is an angle alpha between the head and the tail of the other vector, and the two vectors are connected head to tail to form a triangle. And R is the resultant, which is not an ordinary arithmetic addition, but rather there is some mathematical way to add these two vectors. Let us see these vectors once again. This is vector A and this is vector B. And then we move vector A and vector B so that they join to form a triangle of this form, or possibly we can also join them in such a way that they can also form this triangle. If you wanted to compare it with the original problem, that is above vector A and vector B, and the below two arrangements are to form a triangle from each one of the two vectors. This is called the triangle method of vector addition. In this instance, I want you only to recognize how vector A and vector B are joined together to form these triangles. But later on, after a few minutes, we will also see the mathematical description of how these two vectors are actually added together. Now let us move on to the vector addition using the parallelogram method. If this is vector A and this is vector B, we can, in a similar way as we did for the triangle method, we can join them together to form a parallelogram. This is the parallelogram method of vector addition. And the two vectors, as you can see here, are joined tail to tail. But in the case of triangle method of vector addition, we joined them head to tail. But now they are connected tail to tail. If this is vector A and this is vector B, now we can connect them to form a parallelogram. The above two arrows, vector A and vector B, are the original given vectors, and the parallelograms that you see down here is the parallelogram which is connected using the two vectors. The way of arrangement is called the parallelogram method of vector addition. Now, as I promised to you, we move on to the mathematical derivation of the two methods. First, we begin with the triangle method of vector addition. The triangle method of vector addition, if we have vector A and vector B, so that they form a triangle of resultant R, and then we join to form a right-angled triangle here with an extension. This is an angle alpha, and this is, of course, theta is 180 degree minus alpha, because the angle of straight line has to be 180 degree. If we decompose B, we get B cosine theta, and the height is B sine of theta. So the base of the triangle is simply a plus b cosine of theta, as you can simply see it from the diagram. Likewise, the height of the right angle triangle is b sine of theta, and using the Pythagoras relation, we can join the base squared plus the height squared equals the hypotenuse squared. So we can simply, upon simplification, we get r squared is a squared plus b squared plus twice of ab times the cosine of the angle theta. If you wanted to express it in terms of alpha rather than theta, we simply substitute theta by 180 degree minus alpha to get r squared is a squared plus b squared minus of 2ab times cosine of alpha. Have a look at the difference between these two formula, the case where we use this angle theta and the other time angle alpha. Now we move on to the parallelogram method of vector addition. Now is the time for its mathematical derivation. We have two vectors, vector b and vector a, which are joined together to form a parallelogram. This is the resultant vector. As you notice, these two vectors are connected tail to tail. The angle between the two tails is theta is 180 degree minus alpha. In a similar way as we did before, we extend so that it forms 90 degrees there. And with the same mathematical procedure as we did before, we can simply and easily show that r squared is a squared plus b squared plus twice of ab times the cosine of theta. In fact, the derivation is very similar to that of the triangle case. This is a parallelogram method, and r squared is a squared plus b squared minus twice of ab times cosine of alpha is for the triangle method of vector addition. I want you to recognize that in case of parallelogram method, we use angle theta, that is the angle between the two tails. And in case of triangle method of vector addition, we use angle alpha, which is the angle between the head and the tail of the two given vectors. Now let us recap what we have seen. In the triangle method of vector addition, we have said that if this is vector A and this is vector B, we join them together to form a triangle in such a way that they are connected head to tail, forming an angle alpha between the head and the tail of the other vector. They form a triangle, and we use this formula to find the resultant vector. The second important thing we have seen is a parallelogram method of vector addition, where the given two vectors A and B are joined together to form a parallelogram. And in our parallelogram, the resultant is this vector r. In this case, the angle theta is the angle that occurs between the two tails of the given vectors, and we use this formula to find the resultant. It is also very important to know the sine and the cosine laws once we find the magnitude of the given vector with the help of the formula that I showed you earlier. If you are once again required to find the corresponding angles, the cosine law and the sine laws will help us, and you need to keep this in mind as well. So the sine and the cosine laws are used to relate the sides and angles of the triangle, and we use them to determine the angle between the two vectors. Now let us see this example. The first one is determine the resultant force, where F1 is 400 newtons, F2 is 500 newtons. They are joined head to tail, and the angle between them is 130 degrees. As you can clearly see that they simply form a triangle, so we directly apply the formula for the triangle method of vector addition. Upon direct substitution with an angle alpha 130 degrees, we get 817 newtons. The second is determine the resultant force R is F1 plus F2. Now the given force is at 20 degrees from the horizontal, and the magnitude is 450 newtons. We have another force F2 of 300 newtons, and the problem is to vectorially add these two together to form a resultant R. So we reconnect them so that this is a given F2 and this is F1, and this angle is given to be 20 degrees. I have simply reconstructed the given two vectors. So this is 180 degree minus 20, which is 160 degrees. This is the original arrangement, and this is the rearranged tail to tail to form a parallelogram. So because they are connected tail to tail, what we are going to use is to directly use the parallelogram method of vector addition. Upon direct substitution, we get 197 newtons. Alternatively, if we are asked to use the triangle method rather instead of the parallelogram method, I'm going to use the same problem, but this moment the triangle method is going to be employed. So this is the same problem. So if we wanted to reconstruct them into a triangle rather than a parallelogram, what we do is as follows. This is F2, this is F1. As you can clearly see now, they are rearranged into a triangle with resultant R, so we directly use the triangle method of vector addition. This is the original arrangement, the original problem. This is what I have reconstructed to form a triangle. Because they are connected into a triangle that is head-to-tail arrangement, we are going to directly use the triangle method of vector addition. With direct substitution, we get once again 197 newtons, the same answer as before. The fourth example is for the force arrangement shown below. Determine the magnitude and direction of the resultant force. This is a force at 15 degrees from the positive x-axis. F1 is 100 newtons. Another force is F2, 150 newtons, which makes 10 degrees between the positive y-axis, as you can see here. So the question is to determine the magnitude and direction of the resultant force from this arrangement. We can go ahead with solving this problem like this. This is F2, exactly as it is given there. This is F1. So first I wanted to create this arrangement with resultant R. This angle is 15 degrees. This is 10 degrees, that is already given in the problem. This makes 90 degrees, that is on the coordinate system between the positive y and the positive x-axis. So from that, we can directly determine the angle between the tails of the two vectors to be 90 minus 15 minus 10, which is 65 degrees. And this angle is, let me call it theta, and the angle of elevation of the resultant from the positive x-axis is r. That is actually the direction of the resultant force. That is part of the problem actually. And if this angle is alpha, because the sum of the interior angle of any quadrilateral has to be 360 degrees, from that requirement we can determine alpha to be 115 degrees. So we can now use the triangle method of vector addition with the help of this resultant, this F1 and this is F2. So with the help of this angle alpha, I can use the triangle method of vector addition. With direct substitution, we can get 213 newtons. Applying the law of sine, I can move on to determining the angle theta first, and then I will add theta to 15 degrees to get phi. So in order to get theta, this is F2 divided by sine of theta is equal to R divided by sine of alpha, which is 115. Directly using the sine law, I can find that theta is 39.8 degrees. And because the resultant, the direction of the resultant force from the positive x-axis is required, that is simply phi is required. In order to get phi, we add phi is equal to theta plus 15, which is simply 54.8 degrees.